Hey everyone, Ivan here. Today I'm talking about to the fascinating topic that sits at the intersection of neuroscience and technology. How our brains differ from computers. While we often use computer metaphors to describe how our minds work, like processing information or storing memories, the reality is that these two systems function in profoundly different ways. As someone that loves to do software development most of the time and works with computers daily, I've always been fascinated by how my own brain approaches problems differently than the machines I program. The more we understand these differences, the better we can develop AI systems that complement human intelligence rather than just trying to replicate it. In this video, I will walk you through the key differences between brains and computers, from how they process information and store memories to their energy efficiency and ability to adapt. I'll show you real examples from both fields to help visualize these differences. So let's start by examining how these two information systems fundamentally operate. According to TutorialsPoint.com, that is a well-known software development webpage, in the field of cognitive science and artificial intelligence, the knowledge of brain and computer is very useful. In artificial intelligence, the brain is analyzed and used to model different kinds of artificial neural networks to develop a computerized expert system. The basic difference between the brain and computer is that the brain is a natural organ of human body that can make decisions on its own, while the computer is a man-made machine that requires sufficient data and instructions to make a decision. So if we see in the human brain is quite a complex and abstract system. It is constituted with neurons and synapses. A typical human brain contains around 100 billion neurons, or it's about 10 out of 12 synapses per cubic centimeter. A human brain has a capability to encode, retain, and store the information. This ability is termed as memory and is place of brain where all the information, learned processes, and past experiences retain. In the brain, neurons are the living cells that use as the storage unit. These neurons are made up of synapses. Synapses are responsible for transmitting the electrical neural impulses from one neuron to another. One most interesting characteristic of the human brain is that it has infinite storage capacity. That's really amazing. Another important thing about the human brain is that it does not have a definite topology like a computer network, but it keeps changing its topology regularly with the learning of the person. That's really huge, vast amounts of information in the brain. That's really different from a computer, as you can see. What's a computer? A computer is an electronic device that can perform attacks based on instructions of the user. A computer can perform several attacks based on its programming. A computer is a very powerful machine that can process billions of instructions in a few seconds. But when we compare with the human brain, it is far backward. It is because a computer needs user instruction for data processing and also perform those tasks for which it's programmed. That means it cannot make decisions on its own. A computer built up of several electronic components like transistors, logic gates, capacitors, diodes, etc. All of these electronic components are connected in a certain fashion to realize the circuit of the computer. In a computer, several types of memory devices are used to store data and information. These memory devices have a fixed storage capacity. When we need to share information about different computers, we have to establish computer networks having a defined topology. So we're gonna see that the difference between brain and computer in this table. So in the human brain, the brain is constituted with neurons and synapses, and a computer can be constructed using IC, transistor, diodes, capacitors, and transistors. In the human brain, the memory growth of a brain increases every time synaptic links are connected, while in the computer, the memory growth of the computer can be increased by adding memory chips to it. The brain has a built-in backup system. The backup systems are manually constructed in the computer. In the brain has a memory power of about 100 teraflops, approximately 100 trillion calculation per seconds. It's an amazing, vast amount of memory. Computer has a memory power is about 100 million megabytes. Still, supercomputers can have right now this kind of 100 teraflops. I can believe yes. Well, the memory density of the brain is 10 out of 10 circuit per cubic centimeter, and a computer has a memory density of 10 over 14 bits per cubic centimeter. Amazing. So as you can see, there's a lot of information about this, this human versus computer, and it's not the same. It is not quite the same because this is an organical, I can say machine. This is not a machine. This is a human being living, and a computer is just a machine. We're trying to abstract away from the human perspective. So we're trying to build more abstractions from the computers in order to us to understand it as humans. So the more abstraction we do with computers, the more we understand it as humans. This is another website that, according to the Gray Matters Journal, vc.org. So is the brain-computer debate. Is the human brain like a computer? So there is a huge debate here. There's a lot of information in this website. So just gonna read a little bit. In the late 1940s, pioneer computer scientist Alan Turing is more regarded in the software development as the father of software. Asked what it would take for a machine, for a computer to think for itself, Turing predicted that by the year 2000, while we'll be able to speak of machines thinking without expecting to be contradicted. Turing's comment was admittedly a bit optimistic. Now, over 70 years later, there is a debate amongst philosophers, neuroscientists, and computer scientists regarding the similarities between the brain and digital computer. If machines could theoretically think and process information like the human brain, would this mean that human brains process information like machines? To begin answering this question, let's delve into the architectural differences between a typical digital computer and the human brain. As I told before in the first part, this is another way to say it. So transistors versus neurons, how do computers and brains compare? Our first instinct may be to think as a computer as a consumer device such as a Mac or a PC or a smartphone. However, a plethora of different computer types exist, ranging from the most primitive and now analog computers to massively complex quantum computers. Still, quantum computers just exist in just as big machines at IBM and at Google and other three companies. I've already did a topic about that, those kinds of computers. According to some neuroscientists, a computer is generally any system that transmits signals, integrates information, and converts inputs into outputs, like a function in math. While the brain and the computer both process information, defining a computer as something that receives information, manipulates it, and determines output does not account for the embodied nature of a human brain, nor the impact of external processes and environmental factors on cognition. Modern computers are largely based on the von Neumann architecture, first developed in 1945. A von Neumann-based computer uses a single central processing, the so-called CPU, which load and execute instructions, as well as memory unit that holds instructions and data. There are also peripherals or output devices that send data to human users or other computers. As well, we know the keyboards and mouse. The CPU, memory unit, and peripherals are well connected via communication systems known as buses. A computer constructed around the von Neumann architecture processes information sequentially, following the specific order of instructions encoded in the memory unit. It's more like a kind of you see like this one. This is more like it's really more like following a kind of instruction synchronously, step by step. Just you enter the input by your keyboard and the control unit process, and it has a memory unit that we would call the can be RAM, or it can be the ROM. So one is processed, and the RAM is the actual resources that it have at the moment, right? But once you have you will have the output from the device, so you will have the presentation in the screen, or can be an output will be sound, whatever. In contrast to von Neumann-based computers, the human brain engages in parallel processing, or the processing of multitasks continuously and all at once. Most sensory and motor system neural pathways, for example, intersect several brain regions. Even within each brain region, there are multiple neural networks that operate at the same time. In this way, the human brain's architecture differs from the more rigid von Neumann model, in which information is processed in discrete sequential intervals. It's a way more complex our brain. Notably, however, computer systems that process in parallel do exist, such as those with more than one processing unit. In fact, modern technologies like the iPhone implement parallel processing. It's a way right now, this modern time, it's really more well known with this kind of when you see in the cores, when they tell you it had 4 cores, so it can run in parallel. That's what we're talking about this article. Before taking a position in debate, it's imperative to consider prevailing arguments, considering the structure of the human brain relative to a computer. Some academics have argued that the biological brain functions as a massive parallel computer. For example, computer scientist Marvin Minsky argues that the human brain is formed by several agents, aka into transistors in a computer, each of which is mindless. Together, these agents create a mind by processing information simultaneously. Others broadly define a computer, arguing that both the brain and the computer essentially complete the same task, information processing. In addition to many philosophical arguments conceptualizing the human brain, the inability to isolate what in particular contributes to parallel processing in the human brain poses an obstacle in driving comparisons. Several computational models have been employed to study or attempt to simulate the parallel processing characteristic of the human brain, yielding results suggesting that parallel processing of various tasks in the human brain occurs at the level of neural regions rather than individual neurons themselves. However, many questions remain unanswered regarding the precise role of individual neurons, neuronal connections, and structural regions that contribute to parallel processing in the human brain. For example, we have not yet been able to determine how many processes the human brain is capable of processing at the same time, until the precise mechanism of parallel processing within the human brain is elucidated. Equating the human brain to a computer may be an apples to oranges comparison. As you can see, it has a lot of information. This is a nice web page to learn, to read. Once you read it all, you will have a clear understanding what is the brain and the computer. That's a really nice web page. So there you have it. While both brains and computers process information, their approaches couldn't be more different. Computers excel at precise calculations, following exact instruction and storing specific data points perfectly, while requiring about 100 watts of power compared to our brain's mere 10 watts. Our brains, on the other hand, shine with their incredible adaptability, creativity, problem solving, and parallel processing. The neural networks in our brains can reorganize themselves based on our experiences and learning, showing remarkable plasticity that fixed algorithms in computers simply don't possess. Perhaps the most fascinating difference is how our brains process information, unlike computers that process identical inputs in the same way every time. Our brains never process the same information exactly the same way twice due to the constantly fluctuating state of our neural networks. This variability might seem like a bug, but it's actually a feature that enables creativity and helps us see connections computers might miss. So in short, understanding this difference isn't just academic. It has real implications for how we design technology and AI systems. Rather than trying to make computers function exactly like brains, we can leverage the strength of both, creating technology that complements our human ability instead of trying to replace them. Well, if you find this interesting, please consider to hit that like button and also subscribing for more content where we explore the fascinating intersection of technology and human experience. This is Ivan, and I'll see you in the next video.